Hello students, Namaste. Very warm welcome to you in this class on the topic force and motion. I am Sushil Chandra Gautam to teach you here the science subject, and I am going to teach the topic force and motion today. So all the students are requested to see this video till the end. Okay, before defining the term force, we are going to define or we are going to know about the two terms rest and motion. Rest and motion. Then firstly, what is rest? Before knowing this term, we should be clear about the two terms, that is the term reference point. Reference point. To know this, for example, let us take one example. This body, that is, this is marker, and here this marker is in the position of state of rest. It is because its position is not changing with respect to the surrounding. You can see here, this the position of this marker is at the same distance in every time from each and every corner. If you see this from this point or from my nose, from every point, it is at the constant distance. That's why it is in the position of rest. But if I am moving this marker in this condition, its position is changing with respect to the surrounding or the reference point. That's why it is said to be in motion. That's why reference point is what? Reference point is the point, or reference point or frame is the point or frame in the space which is taken to know or to compare the position or state of body, that is either rest or motion. We can easily define it. After knowing about the reference point and reference frame, we are going to know about the rest and motion. As we have already taken that example, rest, according to the example, rest is the state of a body in which the body does not change its position with respect to the surrounding or with respect to any reference point. And motion is also a state of a body which changes its position with respect to the surrounding. Here it is in the state of motion and it is in the state of rest now, because in every time it is at the same distance from any point, and in this condition it is changing its position. That means its distance varies from place to place according to the reference point. Okay, after knowing about the rest and motion, why the body comes or why the body changes its state, either rest to motion or motion to rest. For example, simple example, it is in rest now, but when I apply some force here, it comes in motion. Or if now it is dropping from here, but when I apply some force, at that time it comes in rest. Means to change the state of a body, that is rest to motion or motion to rest, we should apply some amount of force. Then what is force? We are entering to our topic. What is force? Force is an external agent that we apply from the outside. Means that force is an external agent that changes the state of a body, that is rest to motion or motion to rest. That's why we can easily define what? Force as an external agent. What does it mean, that agent? Agent means the external things that brings some change in the state of a body. That's why force can be defined as the state of a body that is rest to motion or motion to rest if it is in rest. And it is not necessary to change compulsorily. Suppose, for example, this is a board here. I am applying some external force from here, but it is not moving here. Does it mean that I am not applying the force? No. I am applying the force. It is not compulsory to change the state of a body. Either change or tends to change. Tends to change means near to change about. If it was not any support, if there was not any support in this corner, at that time the wall would fall down. Means that after applying the force, the body changes or tends to change the state. That is from rest to motion or motion to rest. For example, if anything is moving and if I apply some force from here, at that time it will get stopped. Why? Because of my force. If there was no any force, the body would continue its motion. That's why force is an external agent that changes or tends to change the state of a body, that is rest to motion or motion to rest. Okay, then now, after discussing about these terms, we are moving towards the types of motions. There are basically two types of motions. Okay, that is uniform motion and non-uniform motion. Be clear here. I will give you an example here to know about the uniform and non-uniform motion. Okay. Uniform motion. Uniform motion means if a body, for example here, if a body travels, suppose the body A, travel 10 meter distance in 2 seconds. Here also 10 meter, 2 seconds. 10 meter, 2 seconds. 10 meter, 2 seconds. 10 meter, 2 seconds. Likewise, if a body travel equal distance in equal interval of time, then it is called uniform motion. Uniform motion. Motion means either it may be speed or velocity. You know about it because you have already read in class 6 and 7 this. Okay, if you are going to calculate speed or velocity, velocity means displacement per unit time, or speed is defined as the distance traveled by time. Distance is how much? 10. Time is how much? 2. What will you get the result? 5 meter per second. In this case also 5 meter per second. In this 10 by 2, 5. 10 by 2, 5. 10 by 2, 5. In every second or in every time or in equal interval of time, the body travels the same distance. Means that uniform motion is defined as a type of motion in which a body travels equal distance in equal interval of time. That is called what? Uniform motion. Then what is non-uniform motion? Non-uniform motion means if a body travel here 10 meter in 2 seconds. Suppose this path is zigzag, this path is uniform. 10 meter, here it travels 15 meter or 16 meter, here it travels 20 meter, here it travels 30 meter, here it travels 4 meter. The time interval is same, 2 seconds. Here also we took the same time interval, 2 seconds. And in this time interval, the body travels equal distance here. But in this case, there is the same time interval, but the body travels on equal distance. Here 10 meter, 16 meter, 20 meter, 30 meter, 4 meter on equal distance. At that time, what you will get the speed? V is equal to, in this case, 10 by 2. Means how much? 5 meter per second. In this case, how much? V2 is equal to 16 by 2. What? 8 meter per second. In this, V3 is equal to what? 20 by 2. Means that 10 meter per second. Means that the body is not changing its motion or changing its speed. Here the body was not changing its speed, but the speed of a body is varying here. So, non-uniform motion is what? If a body travel unequal distance in equal interval, note it, equal interval of time, time should be equal. If you take the unequal time, at that time also there may be the uniform motion. For example, 2 seconds, 10 meter, 5 seconds, 50 meter, 10 second, suppose it travels 100 meter, at that time 10 by 2 how much? 5. 5 means 20. 5 who's at 20 means 25. 25 means 10, 25. 25 means 25 by 5. How much? 5 meter per second. Here also 5 meter per second, here also 5 meter per second. But both the time and distance are unequal here. So you cannot say that unequal distance in unequal interval time. What should you say? If a body travel unequal distance in equal interval of time, then it is called what? Non-uniform motion. Uniform motion what? If a body travel equal distance in equal interval of time, then it is called what? Uniform motion. Uniform motion, in this condition, the velocity, acceleration of a body becomes 0 meter per second square. Why? We will discuss it after discussing the acceleration. Uniform motion, the acceleration will be 0. Why? We will discuss later on. Non-uniform motion is acceleration becomes certain, means the acceleration does not become 0. Okay, after discussing about the uniform and non-uniform motion, I think you got it clearly. We are going to discuss here the other terms, which is related to the motion. Okay, then now, before this, we are going to discuss here about the scalar quantity and vector quantity. Scalar quantity and vector quantity. Vector quantity. Scalar quantity and vector quantity. Scalar quantity are those quantities which do have magnitude but no direction. Which do have what? Magnitude. Have magnitude but no direction, no fixed direction. Vector quantities have both magnitude and direction. What does it mean? What does it mean that magnitude and direction? Two terms are here. These are the most important terms to know about the scalar quantity and vector quantity. Magnitude means value. Simple example, if you are asking to the shopkeeper to buy 10 kg sugar, 10 kg sugar you asked. That 10 kg, that 10 means it is the quantity. But in which direction the mass takes place? In this direction, this direction, this direction, in which direction? It does not have its fixed direction. Simple example, if I give you a 100 rupees note, that 100 is magnitude. Means that your 100 rupees have magnitude, fixed magnitude, that is 100 rupees. That value, magnitude means value. But it does not have its fixed direction. Where does that 100 rupees is directing? We cannot find it. So 100 rupees is scalar quantity. Means that those quantities which have fixed direction, which have not fixed direction but have fixed magnitude are called what? Scalar quantity. For example, another simple example, distance we can take, distance. Suppose you are going from this point to this point, A to B. You are going from point A to B. You can follow any path. In this way also you can go. You can go straightly. You can go by this path also. You can go this path also. Any path you can follow. Suppose if you are following this path, this is 100 meter, this is 150 meter, this is 10 meter, that is straight path is 10 meter, this is 20 meter. Here you can see, if you follow the path, this path, at that time it has 100 meter fixed magnitude. But does it have fixed direction? Here it is directing up, here it is directing down. Means that if you follow this path, at that time it does not have what? Fixed direction. It has magnitude 100 meter. Value is fixed here, but we do not have the fixed direction. If you are following this path, also it has magnitude but no fixed direction. So this type of quantities are what? Scalar quantities. Means that having value, that is magnitude but no direction, are called what? Scalar quantity. And what is vector quantity? Which have both magnitude and direction. For example, the same point you are going from A to B. I copy this distance here, A to B. If you are following this distance, 10 meter, it has both magnitude and direction here. Magnitude 10 meter, direction is also fixed in this direction. Does it have up and zigzag direction? No, it has fixed direction, so it has both magnitude and direction. So it is called what? Vector quantity. Vector quantity have both magnitude and direction, whereas this scalar quantity have magnitude but no fixed direction. Similarly, here vector quantities are represented by, simple example we have already said, displacement. What is distance and what is displacement? I want to make it clear here, A to B. If you are following this path, that is the shortest distance between the point A and point B. You can clearly see here. Between the point A and B, there is the what? Very short distance. If you follow this path, the path will be longer. If you follow this path, that also will be longer. If you follow this path, that will be longer. there is no any path, no any shorter path than this. That's why, what is displacement? I am going to make you clear here. Displacement, distance also. By same point I want to make you clear here. That the shortest distance between the point A and B is called what? Displacement. The shortest distance between the point A and B is called what? Displacement. Whereas the length between the 2 points is called distance. Distance may be, this also is the distance, this also is a 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 distance. Means distance does not have fixed direction. Whereas displacement, it does have fixed direction as well as magnitude. So we can define distance is the length between the 2 points. That may be 100 meter, 200 meter, in any way you can go. Whereas displacement is the shortest distance between the 2 points. Distance is the what? Scalar quantity. Why? Because it does have fixed magnitude but no fixed direction. Whereas the displacement, it is the vector quantity because it has both magnitude, fixed magnitude and direction. There are fixed magnitude also, fixed direction also. That's why displacement is a vector quantity. Distance is a scalar quantity. Okay, then after knowing about the distance and displacement, it is an example. Scalar quantity cannot be represented by arrowhead sign. It is given, suppose example, displacement. If D represents displacement, then vector are represented by this sign, arrowhead sign. Arrow in the head, the arrow sign is given. It shows that fixed direction. Displacement, vector quantity are represented by arrowhead sign, whereas distance are not represented. Simply we can write it in a simple way without the arrowhead sign. Means it does not have fixed direction. That's why distance, it is the scalar quantity. So you are not allowed to write that arrowhead sign over it. Another difference: scalar quantities can always have the sum positive. Means while you are adding, it always gives a positive result. But vector quantities, it may show either positive or negative or zero result. Means the sum of scalar quantities is always positive. The sum of vector quantities may be positive, negative or zero. In a similar way, scalar quantities, vector quantities, these quantities are represented by arrowhead sign. These are not represented by arrowhead sign. The vector quantities have both fixed magnitude and direction. They do not have, they have magnitude, fixed magnitude, but no fixed direction. In this way, you can write the difference. Thank you very much, everybody. Thank you for watching this video to the end. Thank you very much.